evening and welcome to Tinkering with Edkelar. After another week of work, I finally managed to get the wire recorder electronics connected again. It was an experience. As I mentioned before, the capacitors were beyond safe use. Most of them were the wax paper type, and even my multimeter measured some as resistors, while others were just plain nothing, or at least way off from the nominal value. I took pictures to keep track of which cap goes where, as I didn't have the circuit diagram back then. The power transformer is certainly the heaviest part, as is evident by the bent mounting tabs. Well, those need some straightening out. Also, some fresh paint for the covers. I taped off and preserved the model number. Like with the mechanical parts, I drilled out the rivets that held some of the parts to the base plate, mostly the audio output transformer and the tube sockets. The tin cans are multi-section electrolytics. Those are hard to come by today, but regular ones can be used to replace them. Since I didn't want to add additional components on the underside, I decided to gut the old ones. The new ones should fit into the cans nicely. I did this before with the radio, but these here had the juicy filling stuck to the can. Especially the main filter cap was toasted inside, making the gunk the consistency of caramel candy. I had to use a drill to empty it, which led to a busted can when the drill drifted off a bit too far. At least I could use the hole to scrape out the gunk. One other capacitor, not an electrolytic, just a regular large 1 microfarad one, was also a canned version. Since this one was soldered shut, I tried to use my lathe to get the can open, only to have it get stuck. Again. Now it's getting personal. I just cut it open with a hacksaw, removed the oily insides and hammered it into shape again. There. Good as almost not quite so new anymore. The resistors were way out of tolerance too. 440 instead of 220 kilo ohm, for example. So I ordered a set of replacements and wondered, if I have to replace all of the resistors, why even keep the wires? And that's when I started to desolder the remaining connections. Why replace everything, you ask? Well, for one, most of the wires were in bad shape too. Green stuff between the insulation and copper. Yuck! Another consideration is not as obvious to most viewers. Tubes are heated by design. That means that their operating temperature is quite high. It is not uncommon for some of them to reach over 300 degrees Celsius. That makes the temperature of the pins reach close to the melting point of solder. And since tubes work at a few hundred volts, you definitely don't want any of those wires to become loose. So the choice to wrap the wires around the posts and then solder them is a deliberate safety measure and requires clean posts to begin with. The mains transformer has a surprise on the inside. The center tap lines are connected to ground in that they are jammed inside the core plates. Yikes! I dug them out and soldered on a lead so that I can have a proper grounding to the chassis. The mounting tabs of the electrolytics were brittle. Some broke off during disassembly. I pondered how to fix that and decided to remake something from sheet metal. Drill a hole, screw them together and use the lathe to make a decent round shape. A CNC mill would have been useful here. I had to use my model making one to carve out the inside. Not perfect, but close enough to work. The replacement caps are easy enough. I got some that are very close to the original values and have the highest temperature rating I found. Connecting the negative wires and putting heat shrink on the positive ones to prevent sparks. I used existing holes or drilled a few new ones to get the wires to the outside for proper connectivity. The inside of the cans was still showing some residue of the old gunk, and I already had done enough damage to them. So to contain that stuff at least somewhat, I decided to put a coat of lacquer on the inside. I just dipped it, no use for a brush. And after putting them together again, closing the lid yielded a reasonable version. The potentiometers are next. Open, clean. Oh, these have a different mechanism. The center pin is connected to a tubular piece and a slider pushes that against the outside of the can, where a paper with graphite coating is providing the resistive element. Good thing I'm not somebody to just flood those with deoxy spray. I gave them a good cleaning and, except the paper part, also deoxy, and reassembled them. The tone control has the power switch as a piggyback solution, which meant that I had to rivet it back on. My rivets were just long enough. The two selection switches for play, record and the output channel are in need of some cleaning too. But since they are accessible, these can remain in one piece. I was thinking about disassembling them, but I didn't see any advantage. Besides, the record playback one has the oscillation transformer for the record bias on top. These wires look incredibly fragile, so better not mess with them. The The speaker seems to be in excellent condition. I just use a light brush to get rid of the dust on the cone and a bit of alcohol to clean the frame. Now that the heater lines and the main outputs are connected, let's fire up the transformer. Yes, 6 volt heater voltage and 300 something volts on the input of the rectifier tube. I added it to the socket to give it a try, and yes, it shows a nice rectified sine wave on the output. Woohoo! Visible progress! I tried to finish the wiring for the tubes with the base plate alone, but every other connection goes off to something else. So after soldering some wires to the capacitors, I mounted the base plate to the cover. These tangled layered designs need some careful planning ahead, almost like solving a Rubik's Cube. The schematic for the service manual was useful to mark off any connections I finished, and the reference pictures I made with the capacitors made sure I picked the right pins on the tube sockets. The built to a budget aspect is clear here. To save on standoffs, they made use of free pins on the tubes. Better make sure that you don't put in a replacement tube that has more pins than the intended one. One of the capacitors called for a shielded version, and the original one had a metal sleeve that was soldered to a ground pin. Well, a bit of aluminium foil, a wire, and some Kapton tape make for a good enough replacement, I think. The microphone was in need of some new paint too. Also, the capsule was held in place with pretty badly deteriorated rubber. I used some foam instead. For the fabric, I found something that is very close in color. A bit finer meshed than the original, but it looks very nice indeed. The plug cover got a fresh coat of paint too. Turning it on without the final connections to the head was something I did not want to do. So, mounting the mechanical parts to the chassis, adding the electronics and connecting the last few wires, the head, power supply and the little light bulb between the spools. After double, triple and quadruple checking the connections, sleeping over it once and checking again, powering on one additional tube at a time and checking the output. Yes, the first stage shows voice signal from the microphone. The second stage shows even stronger signal. And the power amplifier? Whoops! In record mode it serves as an oscillator tube for the 36-ish kHz erase bias. And it has quite a bit of voltage on the output. Now here comes the critical part. I want to listen in and see what those 2 spools I got have recorded on them, if anything. And since I'm not sure, I tape off the contact to the erase head. That way it should be impossible to even accidentally overwrite something. There is some music on the first spool. What's that song?
The pioneers have hairy ears to their britches. They wipe hardens.
Oh dear, I can't play that on here. Not only for the possible copyright, but I don't think those lyrics fit my family-friendly channel. Yikes! And our grandparents always said that our generation is perverted. Now, the faceplate. You might recall that I sanded and painted it. I worked on a replacement lettering on my computer. But the idea of silkscreen printing was no good because the plate has high and low spots. Silkscreen needs a totally flat surface or it will not work properly. I looked around and found some water transfer stickers, the kind used by model kits, and printed my design on one of those. I must say, those work like a charm. The ones I have feature transparent background, so they are not suitable for white patches. The background provides the paper color, but the result is quite good, I think. Finishing the assembly, front panel, neon bulb and cover, knobs, and then the big moment, putting it back into the case. The microphone would bang around in the case, so I made a leather bag to protect it. It will eventually rub off the paint, but this way it will hold up much longer. Here's an audio quality test recorded with the microphone.
Good evening and welcome to Tinkering with Escolar.
So, here we go. I sure like the result. And yes, I am aware that this is not a museum level restoration where you keep as much original as possible. But hey, I want to use that thing every now and then without the risk of it catching fire. And that's it for this episode. I hope you enjoyed this rather long project. See you next time! I just use a light brush to get rid of the dust and on the